Dear interstellar traveler, please close your eyes. Let your breath gently synchronize with the heartbeat of Earth. This is a scientific harbor for souls yearning for peaceful sleep. Tonight, let us spread a gentle blanket of knowledge across the vast sea of stars. The sleepy fact you are about to hear are like specks of thought dust drifting in the cosmic depths. Did you know Jupiter continuously plays an infrasound symphony with frequencies 1,000,000 times lower than the human hearing threshold? The pulsar in the Crab Nebula flashes every 33 milliseconds, a cosmic timekeeper more precise than an emerald pocket watch. These relaxing astronomy facts will weave into the most unique, calming space documentary, projecting a personalized space documentary for sleep deep within your consciousness. Aliens might already be too lazy to bother with us. If I were an alien, I'd probably be too lazy too. Although this sounds like a joke or even sarcasm, if we examine this jest on a cosmic scale, you'll find that perhaps it doesn't seem like a joke at all, but more like the truth. Next, I will use for cosmic level facts to explain why alien civilizations haven't made contact with us. 1. We are too remote. In the observable universe, there are at least 2 trillion galaxies in our Milky Way galaxy alone. There are 200 to 400 billion stars, and our Sun is just a very ordinary star in the Milky Way. It isn't even a medium-sized star, only classified as a yellow dwarf. As for Earth, it is not the center of the universe, nor even the center of the Milky Way. Our solar system is merely an inconspicuous dot on the Orion arm of the Milky Way. The stellar density here is about 0.0 for stars per cubic light year. In the center of the Milky Way, the stellar density reaches a terrifying 189,000 stars per cubic light year. That's a difference of almost 72 million times. In other words, we are essentially country bumpkins within the Milky Way, and the Laniakea supercluster, which contains the Milky Way, is located on the edge of the KBC void. On this scale, the Milky Way itself is a cosmic level hick, so our Earth within the entire universe is completely a hick among hicks, too. The universe is too vast when humans stand on Earth and gaze at the stars. We often use the word huge, but in reality, our understanding of huge has been wrong from the start. We say Earth is huge, with a diameter of 12,742 kilometers. Our Sun is huge, with a diameter of 1.39 million kilometers. The solar system is even larger, with a diameter of about 1 light year. But these sizes, on the cosmic scale, don't even count as a fraction. Our Milky Way galaxy has a diameter of 100 light years. The local group composed of the Milky Way, the Andromeda Galaxy, and other surrounding galaxies has a diameter of 10 million light years. The local group, in turn, belongs to a larger structure, the Virgo supercluster, which consists of about 100 galaxy groups and clusters, covering a region with a diameter of 110 million light years and a flat, pancake-like structure. Its central region is about 60 million light years from Earth, and beyond that, there is the Laniakea supercluster, composed of 100,000 galaxies, with a terrifying diameter of 520 million light years. It is the largest scale supercluster to which the Milky Way belongs. but it, too, is just a supernode in the observable universe. These superclusters are connected by the large-scale filamentary structure of the universe, together forming even larger structures in the cosmos under such cosmic scales, not to mention the Milky Way. The entire Laniakea supercluster is just a tiny node, and the starry sky you can see now is only the observable universe we can detect. With a diameter of about 93 billion light-years, according to scientists' estimates, the lower limit for the diameter of the unobservable universe is 23 trillion light-years, perhaps beyond the observable universe. There are countless other universes, countless dimensions, countless physical laws. We are like someone who has never left their village, yet tries to understand the entire universe. 3. Human civilization level is too low. In 1964, Soviet astronomer Nikolai Kardashev classified civilizations into 3 types based on energy utilization capability. A Type 1 civilization can completely utilize all the energy of its home planet, mastering the total energy sum of its entire world. A Type 2 civilization can completely utilize the energy of its star. They might build a Dyson sphere to fully absorb and utilize that star's energy. A Type 3 civilization can control the energy of its entire galaxy. Within this scale, human civilization is only at about level 0.73. We not only lack a Dyson sphere, but even our rockets still burn chemical fuels. For a potential Type 2 civilization, we are like monkeys in the forest knocking stones, yet fantasizing that the giant eagles in the sky will come teach us how to fly. Perhaps in the cosmic civilization database, we are marked as a juvenile civilization, unsuitable for contact, recommended for isolation and observation. 4. Aliens have absolutely no reason to come. We habitually assume that alien civilizations would visit, communicate, or even plunder resources. But from the perspective of cosmic economics, the distances between star systems are too vast. Interstellar travel consumes terrifying amounts of energy, and coupled with the possible finite lifespan of civilizations coming to plunder a cosmic-level backwater like Earth, offers almost zero return on investment. In other words, they have absolutely no reason to come, and we must face a harsh reality. For higher-level civilizations, the knowledge content of human civilization might be far lower than its observational value. It's not that aliens are too lazy to bother with us. It's that they haven't even put us on the dialogue list. But wherever aliens are, whether they are willing to contact us or not, at least it lets us know that other civilizations do exist in the universe. It's just that for various reasons, they see no need to contact us. And if human civilization were the only one in the entire universe, that would probably be the most terrifying thing. The Milky Way is 100,000 light-years in diameter, containing 400 billion stars, but not a single civilization has called us. That's too strange, you know. The Milky Way is 13 billion years old, while Earth is only 4.6 billion years old. This means there were 8.4 billion years, enough for other civilizations to develop and dominate the entire Milky Way. But the reality is, the entire Milky Way is terrifyingly quiet, as if someone pressed the mute button. Scientists have done the math Assuming an alien civilization expands at 1% the speed of light, it would only take 5 million years to colonize the entire Milky Way. But the Milky Way has existed for 13 billion years. In theory, it should have been colonized 2,600 times. Yet we look around and there's nothing. This is the famous Fermi paradox. Either we are too special or there is a terrifying reason why all civilizations have disappeared. Scientists have given this reason a name. The Great Filter. It might be ahead of us, or it might be behind us. If it's behind us, then humanity's doom might not be far off. Humans started sending signals into space in 1977. These signals have now been traveling for 50 years, spreading into the depths of the universe at the speed of light, forming a spherical region with a radius of 50 light years. Within this region, there are 1,400 stars. If any one of them has intelligent life, they already know of Earth's existence. But so far, there has been no response, dead silence. On August 15, 1977, humans received a real mysterious signal once. The Big Ear Radio Telescope at Ohio State University detected a narrowband signal, 30 times stronger than the background noise. It lasted for 72 seconds. The frequency was 1,420 megahertz, exactly the characteristic frequency of hydrogen atoms. Astronomer Jerry R. Emmon excitedly wrote "wah" on the printout, but this signal never appeared again. For over 40 years, scientists have repeatedly searched in that direction, finding nothing. Those 72 seconds were like a phone call from the universe that rang once and then hung up. Even more bizarre, this signal couldn't have come from Earth or the solar system. It couldn't have been a satellite, an airplane, or any known celestial phenomenon. It just appeared suddenly and then disappeared suddenly, leaving an eternal question mark. Some say it might have been a lighthouse signal from some civilization, like a lighthouse at sea sweeping past at regular intervals. We just happened to be within that 72-second beam. Then the beam turned elsewhere, and we might have to wait hundreds or even thousands of years to be illuminated again. But there's another, more unsettling explanation. It might have been the final distress call of some civilization. Their planet was being destroyed. They used their last bit of energy to broadcast a distress signal to the universe, and then everything fell silent. By the time we received this signal, they might have been extinct for centuries. This leads to a deeper question. Perhaps we can't find aliens, not because they don't exist, but because we are searching in the wrong way. All life on Earth is carbon-based life. DNA, proteins, cell membranes are all built from carbon atoms. But why must life in the universe follow Earth rules? As early as 1984, astrobiologists proposed the possibility of silicon-based life. Silicon's chemical properties are very similar to carbon. In theory, it could completely replace carbon as the basis for life. Silicon-based life might live on planets with temperatures of several hundred degrees, with body structures transparent and hard like crystal. They wouldn't need to breathe oxygen, drink water, and could even digest rocks directly as food. They might move slowly, but have extremely long lifespans, possibly living for thousands or even tens of thousands of years. Even more bizarre is plasma life. Plasma is the fourth state of matter with extremely high temperatures and a large number of free electrons. In 1959, astronomer Fred Hull speculated that on the surfaces of some stars or in the depths of nebulae there might exist life forms composed of plasma. They have no fixed shape. The entire race is like a thinking ball of lightning. Drifting through the universe, they might use electromagnetic waves for communication and stellar radiation as an energy source for them. Earth's low-temperature, solid environment would be like hell and suitable for survival. In 2007, NASA scientists proposed a crazy hypothesis on Saturn's moon Titan, where temperatures dropped to minus 180 degrees Celsius. Liquid methane and ethane form lakes and rivers. In this environment, there might exist life forms that use liquid methane as a solvent. They don't need water, don't need oxygen. Their cell membranes might be composed of hydrides. Their metabolic processes are completely different from Earth's organisms. They exhale hydrogen instead of carbon dioxide. More extreme theories suggest that purely energy-based life forms might exist in the universe. They have no physical bodies, no material structure, just some highly organized energy field or information flow. They might float within cosmic rays or reside near the event horizons of black holes, using gravitational waves as perception tools. For such life forms, our detectors simply cannot identify them. Because all our detection methods are based on matter, they might be right beside us, passing through our bodies, and we would be completely unaware. This is like a primitive person who has never seen a mobile phone. If you ask them to find communication equipment, they might bring a mirror or a drum. We have been searching with radio telescopes for 70 years. But if alien civilizations long ago abandoned this primitive communication method, switching to quantum entanglement communication or gravitational wave communication, then we are using a radio to search for internet signals. In 1961, astronomer Frank Drake proposed a famous equation, attempting to calculate the number of communicable civilizations in the Milky Way. This equation contained 7 parameters. For the first 6 parameters, scientists provided optimistic numbers. Only the last parameter became a death trap. How long can a civilization last? Humans have mastered radio technology for just over 100 years. We've had nuclear weapons for only 80 years. We aren't even sure if we can survive another 100 years. If we set this parameter to 100 years, the answer to the Drake equation becomes a terrifying number. In the long history of the Milky Way, thousands of civilizations might have been born, but they all, like fireworks, briefly blossomed and then quickly extinguished, missing each other, never meeting. This is like a relay race spanning billions of years, but each runner can only stay on the track for a few seconds. When you arrive, the person before you has long vanished. The person after you hasn't been born yet. You run wildly on the empty track, thinking you are the only contestant. Scientists have proposed a cruel theory, the Great Filter. This theory suggests that between the evolution of simple life and a civilization capable of interstellar travel, There exists an almost insurmountable barrier. The vast majority of civilizations are destroyed before this barrier. The terrifying part is, we don't know where this barrier is, if it's behind us. For example, the step from inorganic matter to organic matter, or from single cell to multicellular life. Then we have been lucky enough to pass it. If it's still ahead of us, that means there is some almost inevitable destruction waiting for us ahead. Nuclear weapons might be the first filter. The existing global nuclear arsenal is sufficient to destroy Earth dozens of times over. From 1945 to now, humanity has been dancing on this powder keg for 80 years, relying not on wisdom, but on luck. No one can guarantee that luck will last forever. Artificial intelligence might be the second filter, when an intelligence has an IQ 10,000 times that of humans. We cannot even understand what it is thinking. It's like ants unable to understand why humans build highways. Perhaps every civilization, after creating super artificial intelligence, is replaced by its own creation. Climate change might be the third filter. A civilization, before mastering the ability to transform its planet, might first turn its home planet into an uninhabitable hell. Earth has already experienced 5 mass extinctions. Each one wiped out over 70% of species. The 6th mass extinction, caused by humans, is ongoing. Physicist Stephen Hawking repeatedly warned humanity during his lifetime not to actively contact alien civilizations. He said if aliens visit us, the result might be like Columbus landing in America, which wasn't good news for the natives. He wasn't joking. This is a rational judgment based on historical experience. But what have humans done? In 1974, the Arecibo radio telescope sent a message towards the globular cluster M13, 25,000 light-years away. The message contained human DNA structure, the solar system's location, and Earth's population. This message has now been traveling for 50 years. It will take another 24,950 years to reach its destination. If there is someone there, and if they reply, we would have to wait another 25,000 years to receive it. But the question is, will human civilization still exist in 50,000 years? 50,000 years ago, humans were still drilling wood for fire in caves. 50,000 years is dozens of cycles of civilization. The Voyager 1 and 2 probes carry golden records, which are even more outrageous. They are engraved with Earth's precise coordinates, human images, greetings in 55 languages, and music by Bach. This is like lighting a bonfire in a dark forest and shouting, "I'm here, come find me." Astronomer Carl Sagan once calculated that if a civilization reached Type 2 on the Kardashev scale, meaning it could utilize the energy of an entire star, the Dyson sphere they built should produce a distinct infrared radiation signature. We have scanned 100,000 stars in the Milky Way and found no signs of any Dyson spheres. What does this mean? Either no civilization has reached this level, or they simply don't need Dyson spheres, or they are deliberately hiding themselves. The third possibility is the most frightening. Imagine if there really is some universal law in the cosmos that taught all civilizations to hide themselves. Then there are only 2 reasons. Either they are hiding from some danger, or they themselves are the danger. But there is also a slightly comforting possibility. We arrived too early. The universe is 13.8 billion years old. The Sun is 4.6 billion years old. But the most common stars in the universe are red dwarfs. They make up 70% of all stars. Their lifespans are trillions of years long. They are just beginning their stories. If the universe's lifespan is compared to a 1,000-page book, we are only on the first page. The stories of the vast majority of civilizations haven't even started writing yet. We might be among the earliest intelligent life to awaken in the universe. We feel lonely because the party hasn't started yet. We are the first guests to arrive. What does this mean? It means humanity bears a heavy mission. If we truly are the first, then every choice we make could influence the direction of the universe for billions of years to come. We could either become the first light igniting the cosmos, or become a failed case warning those who come after. In 2023, the number of exoplanets discovered by humans surpassed 5,000. Dozens of them are located in the habitable zone. The James Webb Space Telescope is analyzing their atmospheric compositions, searching for chemical signatures of life. Perhaps within the next 10 years, we will find the answer. Whatever that answer is, it will forever change humanity. If we find that life is common, then the great filter might still lie ahead. If we find that life is extremely rare, then every one of us, every living creature, is an incredibly precious miracle in the universe. The silence of the universe is not a curse, but a blank canvas, waiting for the first civilization to paint it with color. And whether humanity can become that civilization depends on every choice we make from now on. Every decision between destruction and hope, the answer is in our hands. In 1950, in Los Alamos, New Mexico, USA, at the Los Alamos National Laboratory where the atomic bomb was developed, several great scientists were having lunch in the cafeteria. They were talking about aliens, faster than light travel, the origin of life, and various issues. Suddenly, physicist Enrico Fermi, known as the architect of the atomic age, asked everyone a question: if advanced civilizations exist in the Milky Way, where are they? Everyone fell silent. These were all great scientists. They immediately followed Fermi's line of thought. This was a thought experiment. Let's assume there is a civilization in the Milky Way, capable of interstellar exploration. They can travel at 1/10 the speed of light. The diameter of the Milky Way is about 100,000 to 180,000 light years. That means crossing the Milky Way would take at most 1.8 million years. Assume this civilization begins colonizing the Milky Way. They first send one spacecraft to each of the Milky Ways for spiral arms. Then, using the destinations of these for spacecraft as new centers, they began exploring the entire Milky Way. Calculated this way, within at most 2 million years, every star system in the Milky Way should have a spacecraft from this civilization. 2 million years in the entire history of the universe is just a blink of an eye. As long as there is one civilization in the Milky Way that reached the stage of interstellar travel 2 million years before humans, they should have already occupied Earth. But Fermi posed the shocking question: where are they? Time moved to 1963. A secret project was underway. At the Pushino Radio Astronomy Observatory in the USSR, the Soviets were using the most advanced radio telescope of the time to search for alien civilizations. Soon, the 31-year-old astronomer Kardashev discovered a mysterious signal. The signal came from the direction of Pegasus. This radio wave, known as CTA-102, varied in intensity over time and had unusually strong radiation in the meter band. As research deepened, Kardashev discovered there were many such signal sources in the universe. How was this possible? How could there be signals in the universe that grew stronger and weaker, fluctuating over time? Kardashev believed these signals might be messages from highly developed alien civilizations to other civilizations. CTA-102 is 8.2 billion light-years from Earth. To transmit a signal over such a vast distance requires terrifying power. Kardashev immediately set out to calculate the energy levels civilizations could utilize. If a civilization's technology could harness all the energy of its home planet, for example, if humans could utilize all of Earth's energy, this is called a Type 1 civilization. The total energy of a planet is approximately YP watts. If a civilization could harness all the energy of the star its planet orbits, for example, if humans could utilize all the sun's energy, this is called a Type 2 civilization. The energy of a star is approximately YD watts. If a civilization could harness all the energy of its galaxy, for example, if humans could utilize the entire Milky Way's energy, this is called a Type 3 civilization. The energy of a galaxy is approximately YP watts. This classification was very imaginative, and the scientific community quickly adopted this hypothesis. This metric for civilization levels became known as the Kardashev scale. What was CTA-100 to that Kardashev observed? It wasn't an alien civilization, but a massive black hole at the center of a galaxy. The black hole was devouring surrounding gas and dust, releasing enormous energy. The light it produced was brighter than all the stars in its own galaxy. Astronomers gave this cosmic wonder a name, quasar. Scientists estimate that at humanity's current development rate, within 100 years, we could reach Type 1 civilization. Within the next 0 years, we could reach Type 2 civilization. Then, in another 2,000 years, we could reach Type 3 civilization. In 3,000 years, humanity could fully utilize the Milky Way's energy. What terrifying power! At that point, the speed of spacecraft wouldn't be just 1/10 the speed of light. It should approach the speed of light infinitely. Viewed this way, the time to colonize the entire Milky Way would be greatly shortened compared to Fermi's era from now on. Within 200,000 years, humanity could colonize the entire Milky Way. If there were a civilization in the Milky Way that reached Type 1 civilization to 100,000 years before Earth, they should be spread throughout the Milky Way. Fermi's question continues. Where are they? Time moved to August 1996. American economist Robin Hanson wrote a highly imaginative scientific article on his personal blog titled The Great Filter. Hanson proposed that the current absence of any detected extraterrestrial civilizations in the observable universe might be due to the possibility that the emergence of intelligent life is extremely improbable. Using Earth as an example, Hansen outlined 9 crucial stages for the emergence of an interstellar civilization. Step 1. A suitable star system and habitable planet. About 4.6 billion years ago, a molecular cloud collapsed and our sun was born. Over the next tens of millions of years, Earth gradually accreted and differentiated, forming a planetary core. Step 2. Emergence of self-replicating molecules. Around 4.0 to 4.2 billion years ago, RNA molecules appeared on Earth. RNA can store genetic information. This is the oldest known trace of life. Step 3. Simple prokaryotic single-cell life emerged. Around 3.8 to 4.1 billion years ago, simple prokaryotic single-cell life appeared. Bacteria and archaea. Initially, they were anaerobic because there was no oxygen on Earth. Around 3.0 to 3.5 billion years ago, cyanobacteria capable of photosynthesis evolved. Cyanobacteria slowly release toxygen over an absolutely long span of 1 billion years. Cyanobacteria finally changed the atmospheric composition. This period is known as the Great Oxidation Event. The Great Oxidation Event was a watershed in life's evolutionary history. It was an energy revolution because the energy efficiency of aerobic respiration is 18 times that of anaerobic fermentation. Cells could support more complex structures and metabolism, creating the conditions for Step 4. Step 4. Complex eukaryotic single-cell life emerged. Stable oxygen supply was like a big battery for energy metabolism, allowing cell volume to increase by over 1,000 times. Around 1.8 to 2.1 billion years ago, an ancestral archaean engulfed an ancestral bacterium, giving rise to the first eukaryotic single-celled organisms. This branch later diversified into organisms including animals and fungi. Some eukaryotes engulfed cyanobacteria. Since cyanobacteria could perform photosynthesis, they evolved into chloroplasts. This group of eukaryotes initially existed as algae, and later some evolved into today's plants. The evolution from prokaryotic to eukaryotic cells took another 300 to 600 million years. Step 5. Sexual reproduction emerged. Around 1.6 to 1.8 billion years ago, as cell metabolism became more vigorous, the side effects of oxygen increased. Oxidation increased the risk of DNA damage. Antioxidation became a major problem, promoting the evolution of sexual reproduction. Sexual reproduction allows different genes to mix, giving damaged genes a chance to be replaced by healthy ones. Genetic recombination brought higher genetic diversity, improving organisms' adaptability in complex environmental changes. Step 6. Multicellular life emerged. Previously, all life was single-celled. If a cell died, the entire organism died. Around 1.2 to 1.6 billion years ago, multicellular organisms evolved. Even if some cells die, the multicellular organism could still survive. Different cells could perform different tasks, such as movement, feeding, reproduction, and defense, greatly improving overall survival capability. Around 600 to 800 million years ago, large, complex multicellular communities appeared, the ediacaran biota. Step 7. Two using intelligent beings emerged 3.3 million years ago. Australopithecus first began using tools. They are the direct or collateral ancestors of the genus Homo. The famous fossil Lucy is considered one of the possible ancestors of Homo. Finally, the bearers of civilization, humans, appeared. Step 8. Civilization with interstellar colonization potential. About 400 years ago, during the era of Galileo and Newton, humans began systematically understanding celestial mechanics and physical laws. The modern scientific revolution began. In 1957, the USSR launched the first artificial satellite, Sputnik 1, marking humanity's entry into the space age. The next step is the final step, interstellar colonization. In the not-too-distant future, humans will step into deep space and inhabit other planets. The above are Hansen's classified 9 stages. For an interstellar civilization, Hansen called this 9-step process the Great Filter. Why call it the Great Filter? Because failure to complete any single step could filter out or prevent the emergence of an interstellar civilization. Recall Step 3, the Great Oxidation Event. Tiny cyanobacteria releasing oxygen took about 1 billion years to transform the entire Earth into an oxidized planet. From a human perspective, 1 billion years is almost a quarter of Earth's entire history. This process is shockingly long and arduous. According to the Great Filter theory, this might be the reason why aliens haven't arrived on Earth yet. If the filter occurs before Step 8, it means that the evolution of life to humanity's current stage is a miracle. The emergence of civilization is an extremely low probability event. Then humanity has crossed almost all the hurdles. We might be one of the very few civilizations in the universe that has made it this far. But there is another deeply unsettling possibility, called the post-filter era. If many civilizations in the universe reach Step 8, then why haven't we detected any signals from them? This suggests that when a civilization develops to this stage, it inevitably faces enormous dangers, such as nuclear war, runaway artificial intelligence, climate and environmental collapse, etc. When the intellect and cognition of an intelligent species cannot match its technology, the civilization is destroyed. If this is the case, then there's a high probability that human civilization will also be destroyed in the near future. Although the Great Filter theory is a thought experiment, it contains profound philosophical truth on a cosmic scale. The window for a civilization to develop to Step 8 might be extremely short. Humanity's current historical stage might only last a few hundred or even just a few dozen years. Once we take the wrong path, we might disappear forever. If intelligent civilizations are exceedingly rare in the universe, then human civilization is incredibly precious. We must not destroy ourselves. We must survive, if only to prevent the entire universe from falling into eternal silence. Many friends have heard of the theories mentioned above. Next, we enter the most mind-bending part of today's program. Where exactly are the alien civilizations? Everyone knows our universe has an iron law, the second law of thermodynamics, also known as the law of entropy increase. Entropy is a physical quantity describing the disorder of a system. The entropy of an isolated system always increases, and this system will eventually enter a state of stillness and death. Due to having no usable energy left to perform work, life is an anomaly in the universe. The emergence of life is a process of entropy reduction. Look at our Earth. Most areas are vibrant and full of life, a picture of order. Of course, this order comes from the sun's energy. Local order on Earth comes at the cost of greater entropy increase in the wider universe, snowflake crystallization, lightning in the atmosphere, hurricanes over the ocean. These are all spontaneously formed ordered states. But life is different. Plants grow steadily through photosynthesis. Bees build exquisite hexagonal honeycombs. Human cells maintain survival through metabolism and self-repair. This is active order. One of the founders of quantum mechanics, Erwin Schrödinger, once said, "Life feeds on negative entropy," meaning life itself is entropy reducing. Life has another major characteristic. It can create order. Humans invented cars for transportation, built satellites to go into space, and constructed cities, the pinnacle symbol of civilization. These local entropy reduction phenomena are not formed spontaneously. They are created by life's information processing capabilities. They are extensions of life's entropy-reducing activities. One could say the goal of civilization is to create local processes of entropy reduction. Suppose there is a civilization that has fully achieved energy control, able to utilize and recycle any form of energy, even extract energy from the vacuum field. They would no longer be limited by planetary resources or the lifespan of stars. Since they have solved all survival and resource problems, they no longer have the motivation to expand outward or colonize new worlds. Then is it possible that the absence of alien civilizations is not because there is no other life in the universe, but because that life has evolved to a state of existence? We simply cannot imagine. They don't need to interact or communicate physically with the outside world. I call such a civilization a zero-entropy civilization. Let's continue the assumption if a super-civilization reached the zero-entropy civilization stage, when they could fully utilize planetary resources, then they wouldn't need to further develop stellar energy. Currently, the most effective method we know for developing stellar energy is the Dyson sphere, building a massive energy collection structure, encasing the star. However, observing in all directions from Earth, we haven't found a single Dyson sphere structure in the universe. This might indicate that Kardashev's Type 3 civilization is a false concept. The next civilizational form after reaching Type 1 isn't Type 2, but zero-entropy civilization. Some friends might say, that's not right. If zero-entropy civilizations exist, why haven't we received any signals from them either? This requires further discussion of the concept of entropy. Besides thermodynamic entropy, there's another increasingly popular concept in recent years: information entropy. What is information entropy? From the perspective of information theory, entropy is a measure of the disorder of information. High entropy equals chaotic, random, meaningless information. Low entropy equals structured, encodable, predictable information. Some scholars propose that cosmic evolution isn't simply material evolution, but a process of information being filtered from disorder to order. Earlier, when introducing thermodynamic entropy, we mentioned galactic structures, life, technology, civilization. These are all locally entropy reducing and meaning ... Similarly, galactic structures, life, technology, civilization are all products of meaningful information and are also entropy reduction in terms of information. Suppose a civilization approaches zero thermodynamic entropy. What consequences would that have? Minimum thermodynamic entropy means the system's structure does not change over time. All states remain stable. Under these conditions, no new uncertainty is generated because everything is known. Information entropy approaches zero. So, a thermodynamic zero entropy civilization would also have zero information entropy. The existence of a zero entropy civilization means they already know all the secrets of the universe, where the universe came from, what its ultimate fate is. A zero entropy civilization would not communicate with the outside world in any way, silently acting as observers of the universe because there is no more information flow. Humans cannot receive signals from zero entropy civilizations. In the past, we always thought super civilizations would be expansive. Perhaps this view itself is wrong. True super civilizations might choose to optimize energy and information cycles to the limit within a finite space, rather than expanding outward infinitely. Where are the alien civilizations? The zero entropy civilization is one possible solution to the Fermi paradox. Do zero entropy civilizations really exist? This is, of course, just a thought experiment. Since it's a thought experiment, let's allow our thoughts to soar even more freely. When a civilization reaches the state of zero entropy, their existence has transcended energy and information, even transcended physical laws themselves. There, time no longer flows, space no longer extends. The zero entropy civilization doesn't need to travel because they are simultaneously everywhere. They don't need to communicate because they have merged with all things. Perhaps the starry sky we gaze upon is not empty, but filled with invisible intelligence. It's just that we are using the wrong senses to listen, the wrong language to ask. Where are the alien civilizations? The true answer might have always been right beside us, in the ground beneath our feet, the air we breathe, even in the deepest depths of consciousness, waiting for us to reach it through another way of being. In the vast universe, are we alone? The answer to this question perhaps lies within the endless silence. Throughout humanity's search for extraterrestrial civilizations, from the Fermi paradox to the Kardashev scale, from the Great Filter Theory to the hypothesis of zero entropy civilizations, we have looked up at the starry sky time and again, yet only heard our own echo. But this very quest itself is humanity's most touching quality, a curiosity that never extinguishes. Perhaps we are looking in the wrong direction. Alien civilizations may have long transcended physical form, becoming existences we cannot comprehend, or they have chosen silence, observing quietly in a corner of the universe. Or perhaps we have arrived too early. This cosmic party has just begun. We are the first guests to arrive, but no matter what the truth is, this journey of exploration has made us rediscover ourselves. In the process of searching for alien civilizations, we learned humility. Earth is merely a speck of dust in a corner of the universe. We also learn to cherish. Life might be a 1 in a billion miracle right now. The James Webb Space Telescope is analyzing the atmospheres of exoplanets, searching for traces of life, regardless of the outcome. This will be another leap in human understanding. If life is found to be common, we must be wary of the great filter ahead. If life is rare, then each of us is the most precious miracle in the universe. Do not be disappointed by the silence of the universe. This silence is not the end, but the beginning. It bestows upon us a unique mission to become the first awakeners of the universe, to bring the first ray of civilization's light to this darkness. Let us maintain this curiosity and reverence. But even more importantly, hold on to hope, because in the boundless expanse of space and time, we are both explorers and creators. The answer is not in the distant stars, but in every choice we make on the path of scientific exploration, in the actions of environmental protection, in the wisdom of peaceful coexistence. Remember, the meaning of looking up at the stars is not only about searching for aliens, but more about understanding ourselves. What this starry sky ultimately illuminates is the path forward for human civilization. All right, my friend, let's pause our conversation here tonight on the mysteries of the universe. Now, allow me to press pause for you. Set aside all thoughts and inquiries, and simply, quietly be in this moment. From here, my voice will fade away, leaving only the silent tapestry of the cosmos and a carefully chosen piece of pure music tuned to 432 Hz. Science suggests this frequency resonates deeply with the natural vibrations of the universe and the rhythm of life itself, soothing your nervous system and guiding you into deep relaxation. Now, find your most comfortable position. Gently close your eyes or let your gaze rest softly upon the stars. May you release all weariness from the world, letting your consciousness drift on the waves of music, floating into boundless tranquility. Good night, sweet dreams, until we meet again among the stars.